In this video, we are going to look at how we would calculate the gram formula mass of a substance. The gram formula mass of a substance is equivalent to the mass of 1 mole of a substance. We calculate the gram formula mass by adding up the relative atomic masses for each atom in the compound. We're just going to work through some examples now. So, for water, we can see here that we have two hydrogens and we only have 1 oxygen. We've got no little number of acid oxygen, signifying that we just have the 1 here. If you use page 7 of your SQA National 5 data book, you will find all the relative atomic masses there, and you can see on page 7 that hydrogen has a relative atomic mass of 1 and the oxygen has a relative atomic mass of 16. Therefore, our gram formula mass of water is 18 grams per mole. Keeping along the same lines of difficulty, we'll have a look at sodium chloride. There is only 1 sodium here. The relative atomic mass for sodium is 23. We only have 1 chlorine, and its relative atomic mass is 35.5. Add those together and you'll get a gram formula mass of 58.5 grams per mole. Getting a little bit more difficult now, we'll move on to ethane. We have 2 carbons here. Remember, the subscript number refers to the element just before it, so 2 times carbon. Carbon is 12. And here we have 6 hydrogens, so 6 times 1. So we have a gram formula mass of 30 grams per mole. Moving on to number 4, which is potassium carbonate. We have 2 potassiums here, 2 times 39. We only have 1 carbon, we've got no number directly after it. So we've got 1 carbon, which is 1 times 12, and we have 3 oxygens, 3 times 16. And if we add them all up, we will get 138 grams per mole potassium carbonate. Now, moving on to the hardest of these examples by far is when we've got brackets in our formula. So, starting off with magnesium, it's simple, we've got no little number after it, it's just magnesium, which is 24.5. However, when we come to the elements in our brackets, everything inside the brackets gets multiplied by this little 2 that's outside it. So here we have 2 nitrogens, 2 times 14, and we have 2 times 3 oxygen, so it's 2 times 3 equals 6 oxygens, so 6 times 16. And if we add that all up, 24.5 plus 28 plus 96, we get a final answer of 148.5 grams per mole.